Hi, I'm Arpan.
Hi, I'm Aneesha.
Hi, I'm Jenna.
Hi, I'm Chelsea.
And I'm Nivashini, and we're working with Matheny under Dr. Labazo and Dr. Marks. We wanted to start our presentation with a question. Which of these items uses an accelerometer? A phone charger, banana, or a helmet? As you might be able to guess, it is the helmet. In football sports, there's acceleration sensors used to record the speed and acceleration of the helmet.
A large population of students at Matheny suffer with Lesch-Nyhan syndrome, and one of the most concerning symptoms of this disease is the tendency for those who have it to engage in self-injurious behavior. One example of this behavior is headbanging, which is especially dangerous as it can lead to severe head injury. This behavior also affects caretakers as they must constantly watch patients so that they can intervene whenever headbanging begins. For students at Matheny specifically, constant surveillance and treatment of headbanging injuries can take time away from valuable learning and recreational activities. Current market solutions that aim to prevent this behavior include psychotherapy, which is not always effective, and pharmacological treatment, which presents the potential for unwanted side effects. These treatments also offer no protection against injury should headbanging occur. Self-protective gear is commonly used to mitigate injury caused by headbanging, but this gear is often very physically restrictive, which significantly reduces patient quality of life. It also does nothing to prevent headbanging from occurring in the first place. There is currently no market solution to headbanging behavior that is both preventative and protective. Our project is therefore centered on designing a device that is less restrictive than current treatments, preemptively stops headbanging, and protects patients from injury should headbanging occur.
Addressing the population and problem we defined above, we decided to come up with our need statement. It is a way to address the potential headbanging-related injuries resulting from Lesch-Nyhan syndrome in students at Matheny that can reduce the potential and frequency of self-inflicted injuries. Therefore, we're currently designing a protective helmet with an accelerometer motion sensor. It would help to sense when the Matheny patients are about to engage in self-injurious headbanging behavior. The device would alert the caretakers of the patient.
We have chosen a few design inputs in specific that we believe will provide a well-rounded solution. The first design input is specificity. We chose specificity as our first design input as this will allow our device to be more accurate with few false positives to avoid the additional stress of unnecessary and false alerts. To gauge this design input, we desire a successful prototype that will yield less than 10% of false positives when the alarm is triggered. Our second device input is sensitivity. We value this design input as it will be key in ensuring that headbanging behavior will be identified. The benchmarking goal from our prototype will be that it identifies headbanging behavior 90% of the time. The third design input is that it is user-friendly, as caretakers will likely have to help put these helmets on the students. We aim to design our device in a way that allows setup time to take less than 30 seconds. The last input we took into consideration was affordability and that the device will be affordable for Matheny students and families. We already expect the device to be affordable due to preliminary research, in which we found that our materials, such as accelerometers and helmets, are relatively low cost.
Protective helmets already exist in many forms, and some are already in use at Matheny, so we decided to shift our prototype focus to incorporation of accelerometers. These are widely available at a low cost and allow us to assess viability, form factor, and performance of our design. Our first prototype will be a simple accelerometer circuit which can collect data and allow us to narrow down a threshold of acceleration which can signal headbanging behavior. At this stage, it can be attached to a simple bicycle helmet to minimize complexity. An analytical alternative would be to mathematically model headbanging threshold acceleration after some literature review. Our second prototype will be a battery-powered circuit which incorporates accelerometers into a speaker system which activates and produces an audible alarm once the acceleration threshold is passed. Our third prototype will integrate our circuit into a helmet specifically designed for patients with Lesch-Nyhan.
We hope that you can see the impact that our helmet could have on the Matheny population. This device is innovative and practical and can help on multiple levels. First, it will help the students who have Lesch-Nyhan syndrome, or even another syndrome that makes them prone to self-injurious behavior, as it will improve their quality of life and reduce the number of self-harm injuries. The helmet will also benefit the caretakers of the students, as they will have greater ease of mind due to this easy detection of self-harm, and they will be able to focus on other aspects of the students. Finally, the helmet impacts the overall Matheny school, as the educators and administrators will have more time to focus on student enrichment and learning as opposed to reducing injury. Overall, we believe in our device and the impact it will have on the Matheny organization. Thank you for listening.